This is a trigonometry review part 2. So from the last video, we know that sine of a plus b, this is equal to sine a cosine b plus sine of b cosine of a. And then, so what we want to do is we want to look at sine of a minus b and see that there's a connection here. So this is sine of a plus negative b. But if we apply the formula from above, we get sine of a cosine of negative b instead, plus sine of negative b cosine of a. But remember, cosine of negative b is the same as cosine of b. And then sine of negative b is equal to negative sine of b. And if you remember from the last video, cosine is an even function and sine is an odd function. And so we have those two results. And so here, what that says is sine of a minus b is sine of a cosine of b minus sine of a, sine of b cosine of a. So if you notice, we used this identity up above, right here, to get an additional identity. Now, by the same token, cosine of a plus b is cosine a cosine b minus sine a sine b. Now, if we want to take a look at cosine of a minus b, that's the same as cosine of a plus negative b. But this is cosine a cosine of negative b minus sine of a sine of negative b. But this is cosine a cosine b minus sine of a, and we're going to multiply by negative sine b. Remember, sine is an odd function and cosine is an even function. And a negative times a negative is a positive, and so this is cosine a cosine of b plus sine of a sine of b. And so, therefore, cosine of a minus b is cosine, so this is cosine a cosine b plus sine of a sine of b. Now, what we want to do is we want to look at an identity for the tangent of a plus b. But this is sine of a plus b divided by cosine of a plus b. So you could always rewrite it in terms of sines and cosines, right? And so what we have below is sine a cosine b plus sine of b cosine of a. That's the numerator. The denominator is cosine a cosine cosine B minus sine A sine B. Now, what I want to do is I want to divide the numerator and denominator by cosine A cosine B. And I want you to watch what happens. Now, so let's write this down again. We have tangent of A plus B is sine A cosine B plus sine of B cosine of A divided by cosine A cosine B minus sine A sine B. And so if we do that, we're going to get sine A cosine B divided by cosine A cosine B plus sine B cosine A divided by cosine A cosine B. So that's the numerator. The denominator is cosine A cosine B divided by cosine A cosine B minus sine A cosine B, sine A sine B divided by cosine A cosine B. Now, I want you to notice something. In the numerator, notice how the cosine B's cancel, and sine of A over cosine of A. Remember in the last video, we established that that was tangent of A. Okay? Now, the cosine A's cancel, and sine B over cosine B is tangent B. And then the cosine A cosine B, cosine A cosine B, these guys cancel, and we get 1. And then over here, sine of A over cosine A is tangent A, and then sine B over cosine B is tangent B. And we just got ourselves a new identity. So what that says is tangent of A plus B is tangent A plus tangent B divided by 1 minus tangent A tangent B. Now, this is, again, the identity. Now what we want to do is we want to let A equal B. And when we do that, we get tangent of A plus A. We're going to basically get a double angle identity. So we get tangent of A plus tangent of A divided by 1 minus tangent A multiplied by tangent A. And so tangent of 2A is 2 tangent A divided by 1 minus tangent squared A. And so that's the double angle identity for tangent, like so. Now, let's talk about this one. Recall. Sine squared A is 1 minus cosine 2A divided by 2. That was from the last video. Cosine squared A is 1 plus cosine 2A. Okay? this is divided by 2. And so if I want tangent squared of A, this is sine squared A divided by cosine squared A. But this is 1 minus cosine 2A divided by 2. And this is divided by 1 plus cosine 2A divided by 2. But the 2's cancel. And we get 1 minus cosine 2A in the numerator, and in the denominator we get 1 plus cosine 2A. And so that gives us an identity for tangent squared A. And I look at that as another power reducing formula, okay? And so we get 1 minus cosine 2A divided by 1 plus cosine 2A. Suppose we had something like this. Suppose we had sine squared A is 1 minus cosine 2A divided by 2. So what we want to do is we want to replace A with A over 2. And so therefore, sine squared of A over 2 is 1 minus cosine. I'm replacing A with A over 2. So it's 2 times A over 2. And we're going to divide by 2. And so sine squared of A over 2 is equal to 1 minus cosine A divided by 2. So if we solve for sine of A over 2, we get plus or minus the square root of 1 minus cosine A divided by 2. And it depends on where, it's plus or minus because we don't know where A over 2 is. And so so the sign of the radical determines which quadrant A over 2 belongs to, in other words. Now, by the same token, we have cosine squared A is 1 plus cosine 2A divided by 2. And so we're going to replace A with A over 2. And so cosine squared of A over 2 is 1 plus cosine of 2 times A over 2 divided by 2. And so cosine squared of A over 2 is 1 plus cosine A divided by 2. And so cosine of A over 2 is plus or minus the square root of 1 plus cosine A divided by 2. So we have a half-angle formula for cosine. And again, the plus or minus is determined by the quadrant in which the angle A over 2 belongs to. And so over here, if I want tangent squared of A over 2, now we can go right away to this. So we're going to get a half-angle formula for tangent. So this is sine squared of A over 2 divided by cosine squared of A over 2. And remember, we've already established, right, that this is 1 1 minus cosine A divided by 2, and this is divided by 1 plus cosine A divided by 2. And so tangent squared of A over 2 is 1 minus cosine A divided by 1 plus cosine A. And so tangent of A over 2 is plus or minus the square root of 1 minus cosine A divided by 1 plus cosine of A. And that's the half-angle formula for tangent. Now, there's other forms to express that in. There's actually 2 other forms, but we could deal with that at a different, perhaps a different video. Now, this is a simplification that comes up quite a bit in Calc 2. Suppose I ask you to simplify sine squared x, cosine squared x. And so what I want to do is I want to get rid of those powers. So we're going to use those power reducing formulas. And so, and there's a couple ways to do that. It's just I'm going to approach it this way. So you could write this as 1/2 of 1 minus cosine 2x. That's what I'm replacing sine squared with. And I'm going to multiply by 1/2 of 1 plus cosine 2x. But 1/2 times 1/2 is 1/4. So we get 1/4 times 1 minus cosine 2x times 1 plus cosine 2x. But this is 1/4 of 1 minus cosine squared of 2x. But what we really need to know is that that's equal to 1/4 times sine squared of 2x. Okay, now, remember that sine squared x is 1/2 of 1 minus cosine 2x. So what I'm going to do is I'm going to replace x with 2x. So sine squared of 2x is 1/2 of 1 minus cosine of 2 times 2x. So wherever I saw an x, I stuffed in a 2x. And so this is 1/2 of 1 minus cosine of 4x. And so therefore, sine squared x cosine squared x. So what I have is 1/4 sine squared of 2x. But this is 1/4 times 1/2 of 1 minus cosine 4x. But 1/4 times 1/2 is 1/8. So this is 1/8 of 1 minus cosine of 4x. This is very important, and this comes up in Calculus 2. I would ask you in a Calculus 2 class to integrate something like this. And you want to be able to rewrite it this way. And so sine squared x cosine squared x is 1/8 times 1 minus cosine 4x. Now, one tip that I want to give you, when you see something like this, and I give you 1 over 1 minus cosine x. A very standard technique is to multiply the numerator and denominator by the conjugate of the denominator. And so what I'm going to do is I'm going to multiply numerator and denominator by 1 plus cosine x divided by 1 plus cosine x. So this is 1 plus cosine x divided by 1 minus cosine squared x. But 1 minus cosine squared x is sine squared x. So this is 1 plus cosine x divided by sine squared x. And also you want to be aware, a good thing to be able to do is to be able to split off this fraction. And so we get 1 over sine squared x plus cosine x divided by sine squared x. And so again, over here, I'm just rewriting 1 over 1 minus cosine x in a different way. But 1 over sine squared x is cosecant squared x. So this is cosecant squared x plus cosine x over sine x times 1 over sine x. So I didn't do anything fancy. I just wrote sine squared x as sine x times sine x. And so this is cosecant squared x plus cotangent x times cosecant x. And so by rewriting 1 over 1 minus cosine x in this fashion of what I'm boxing, I put myself in perfect position to be able to integrate something like this. So I hope that made sense. Let me give you one more. So if I had 1 plus cosine x divided by 1 minus cosine x. And so here, let me even also add. So, we're going to rewrite this. So we have 1 plus cosine x over 1 minus cosine x. And so, once again, I'm going to multiply numerator and denominator by 1 plus cosine x. So it's just a fancy way to multiply by 1, okay? And so, in the numerator, we have 1 plus 2 cosine x plus cosine squared x. In the denominator, we have 1 minus cosine squared x. And so this is 1 plus 2 cosine x plus cosine squared x divided by sine squared x. And I'm going to split off this fraction. So I have 1 over sine squared x plus 2 cosine x over sine squared x plus cosine squared x divided by sine squared x. And so this is cosecant squared x plus 2, let's rewrite this again. So this is cosecant squared x plus 2 cosecant x, cotangent x, we've already established that, plus cotangent squared x. This is the form you want to be able to rewrite 1 plus cosine x over 1 minus cosine x into. So that's a very important idea. And that'll conclude this video. This is a trigonometry review part 2. Okay, thank you.